Let us now take the sixth module from this topic of mensuration, where we shall discuss some typical questions. Now the first example here says, squares of side 4 cm each are cut from each of the corners of a rectangular cardboard of length 20 cm and breadth 16 cm. What will be the perimeter of the remaining portion of the cardboard? So as you can see here, it says there is a rectangular cardboard of length 20 and breadth 16, which is as shown here. This is the rectangular cardboard, length is 20 and breadth is 16. Squares of side 4 cm each. That means squares of side 4 cm are cut from each of the corners. So from all the 4 corners, we cut out squares of side 4 cm. So these dotted lines represent the cutting out of the squares from each of the corners. Each square is of side 4 cm. So we need to find out what will be the perimeter of remaining portion of the cardboard. So as you can see, when these 4 squares are cut out from the rectangular cardboard, the remaining portion appears as shown in the second figure here. Now total length is 20. From 20 we have subtracted 4 centimeters from both the sides. So 20 minus 4 will result in 12. Similarly this side is 12. Likewise, talking about the breadth here, total breadth is 16, but 4 cm is cut at the bottom, 4 cm at the top. So this remaining portion will be 8 on both the sides. And inside we have 4 and 4 as the lengths. Why? Because these are squares which have been removed of 4 cm each. So we have to find out the perimeter of the remaining portion. We very well understand that perimeter is nothing but the length of the boundary or the length of the given two-dimensional shape. Now here the two-dimensional shape that we have after cutting out 4 squares from each of the corners is as shown. So the perimeter of this shape here can be taken as the sum of all its sides, that is 12 plus 4 16, 16 plus 4 20, 28, then we get 32 plus 4 36 plus 12 48 plus 4 52 plus 456 plus 864 plus 468 and plus 472. Altogether, by adding all these sides, we get the perimeter as 72. So we can say that the perimeter of remaining portion here will be 72 centimeters. Why? Because perimeter is a measurement of length. It should be in centimeters and the given units are in centimeters. So perimeter here will be equal to 72 centimeters for the remaining portion. But friends, if you observe, the perimeter of the actual rectangle also is 72 centimeters. But because length is 20 and breadth is 16, we know that perimeter of a rectangle is 2 times L plus B. So 2 into 20 plus 16, that is 36 into 2 will give us 72 centimeters. So you find that original rectangular cardboard perimeter is 72 centimeters. After cutting 4 squares from each of the corners, the perimeter again remains to be 72 centimeters itself. That means there is no change in the perimeter even after cutting out 4 squares from each of the corners. Let us understand why does this happen? Why does the perimeter remains the same? If you observe, after cutting out 4 squares from each of the corners, the shape of the cardboard completely changes and hence the area will also change, but perimeter remains same because what we have 4 and 4 in the original rectangular cardboard here has become 4 and 4 inside. So the only point is we are cutting it out but the length remains same. So while adding, if you observe, this part is 12, so this is 12 and we take this as 4 and 4. Only difference is after cutting out that square, this has become 12, inside we have 4 and then again we have 4. So no way the length or the breadth here is going to change. So that is the reason the total perimeter remains same even though the shape is changing here. But let me make it clear, this doesn't happen always. Only in this case, when we are cutting out 4 squares from each of the corners, the perimeter would remain same. So we should be able to understand this without even drawing these 2 figures and directly take the answer as perimeter of the original rectangle. So make sure that next time onwards when such type of questions are asked, you are able to visualize what happens and find out the required answer. Why? Because drawing these figures and then finding out the perimeter really takes a lot of time. So simply understand, when we cut 4 squares from the corners of a rectangular cardboard, the perimeter remains same. Area would be changing but perimeter remains same. Why? Because the net length and breadth of the rectangular cardboard remains same. Let us now take one interesting example from model 6 of mensuration. The question says a pit of length 8 feet, breadth 5 feet and depth 4 feet is made in a rectangular field of length 34 feet and breadth 20 feet. The earth dug out of the pit is uniformly spread on the remaining area of the field. What will be the increase in level of the remaining area? So as you can see, a pit of length 8 feet, breadth 5 feet and depth 4 feet is made in a rectangular field of length 34 feet and breadth 20 feet. So this is the rectangular field of length 34 and breadth 20. Inside this rectangular field of length 34 and breadth 20, a pit of length 8, breadth 5 and depth 4 feet is made. That means here is the pit which is of length 8 and breadth 5. And the depth is 4 feet. Understand friends, this is the top view of the field. This pit what is being made here is dug inside up to 4 feet. Now the earth that comes out of this field, earth is nothing but the sand and the mud that comes out, is uniformly spread on the remaining area. So whatever quantity of mud or earth that we get out is uniformly spread on the remaining area of the field. So that is the remaining area. This is the remaining area on which that mud is spread uniformly. So the question says what will be the increase in level of the remaining area. It is obvious that when we spread the mud uniformly on the remaining area, there will be an increase in height, there will be an increase in level. So what will be that increase in level is the question here. Now to solve this question, we need to first find out how much of earth is dug out from this pit. That is, how much volume of mud comes out from the given pit. Volume of this pit will be nothing but volume of the cuboid. Why? Because this pit is in the form of a cuboid. Length 8, breadth 5 and depth 4. So we know that volume of a cuboid is length into breadth into height. So it can be taken as 8 into the breadth is 5 and height is nothing but the depth here, that is equal to 4. So 8 into 5, 40 into 4, 160. This is 160 cubic feet or 160 feet cube, because volume is always measured in terms of units cube. So cubic feet here. So this much of earth or this much of mud is taken out from this pit. And on the remaining area, it is spread uniformly. Let us now find out what is the remaining area. Remaining area, as you can see here, is nothing but this total rectangular field minus the area occupied by this pit. So remaining area can be taken as area of field minus area of the pit which has been dug out. Now the area of the field can be taken as length into breadth. Why? Because it is a rectangular field. So this will be equal to length into breadth, that is 34 into 20 minus area of the pit. Again the area of the pit here is length into breadth. Why? Because this is also in the form of a rectangle. So 8 into 5. Length is 8 and the breadth is 5. So 34 into 20 is 680 minus 8 into 5 is 40. This comes out to be 640. 640 square feet. Remember, this is area. Area is always measured in terms of square units. So because the lengths and breadths here are given in terms of feet, area will be 640 square feet. So now we know that 160 cubic feet of earth has been dug out and the remaining portion on which the mud is spread uniformly is 640 square feet. We have to find out what will be the increase in level. Again friends, going by the concept of volume being constant, that is, whatever volume of earth that has been taken out, the same volume has to be spread uniformly over the remaining area. So one volume that we know is 160 cubic feet. Now this should be balancing the remaining area into the increase in the level. So we can say that the remaining area into the level which has been increased, the rise in level should be equal to the volume of the pit. Volume of pit. Why? Because the volume that we have taken out from the pit has to be spread uniformly over the remaining portion. So remaining area is known to us. If we multiply the remaining area by the increase in level, we get the volume of the pit. So by balancing this now, we can find out the increase in level. Remaining area, as we know, is 640 square feet into, let us take the increase in level as L. This should be equal to the volume of the pit is 160. So from this we can say that L is equal to 160 by 640. This is 160 cubic feet and this is 640 square feet. So upon simplification we get 1 by 4 feet. 1 by 4 feet is nothing but 0.25 feet. So we can say that the level of the remaining portion will raise by 0.25 feet or 1/4 of a feet. So this is how we can solve such typical questions from mensuration by analyzing the shape or figure as given in the question and by applying the relevant formula. So make sure that you remember all the formulae related to 2-dimensional and 3-dimensional figures and apply them at the right place. That's all from this topic of mensuration. See you in the next session. Thank you.